In this video, we'll look at the syntax for accessing individual array elements. The syntax is probably very much like what you expected. We use the name of the array followed by square brackets with the index of the array element we want inside the square brackets. This is called array subscripting. For example, test score sub 1 refers to the element at index 1 in the test scores array. In the code example at the bottom, you can see that we've declared the test scores array of 5 integers and initialize those integers. Then we have 5 output statements that each displays one of those array elements. Remember that array subscripting or indexing starts at 0, so the first element of an array is at index 0. We use the same syntax for storing values in array elements. In this example, we're getting input from the user via the console and updating the individual array elements from index 0 to 4. We could then display them as we did in the previous slide. We'll talk about assignment statements in an upcoming section, but here you can see that I'm assigning 90 to the first element of the test scores array. Notice that the syntax is the same. That pretty much covers the basics of arrays, but you might be wondering how all this works behind the scenes. Let's see. In C++, the name of the array represents the location or address in memory of the first element in the array, that is, the element with index 0. When we access an array element using the subscript operator and provide an index in the square brackets, the compiler knows that you want the element that is at that offset from the beginning of the array. So all the compiler has to do is a pretty simple calculation. For example, if you want the element at index 2, all the compiler has to do is go 2 integers away from the beginning of the array, and there it is. Or 2 doubles, or 2 whatevers. The compiler uses the size of operator to determine where the element will be. This is one reason why raw arrays in C++ are so efficient. But remember, there is no bounds checking, so be careful. If you have an array of 5 integers and you ask the compiler for the integer at the 10th index, it will gladly do the calculation and give you whatever happens to be at that location. It's your responsibility to be sure that you're within the bounds of the array. Now let's head over to CodeLight and use what we learned and write some code with arrays. Okay, so now I'm in CodeLight. And I'm in the Section 7 workspace and the Arrays project. And here's my main CPP file. What I've done is I've created some examples where I'm declaring and initializing some arrays. I'm accessing array elements. I'm reading from them, storing values in them, and so forth. And that way we can go through this step by step so you can really understand what's going on. I've also commented a bunch of this out, and what I'll do is I'll uncomment as I go, and we'll build on this little by little. So the first thing we're doing here is I'm creating an array right here named vowels. That's the name of my array, vowels. And you'll notice that right in those square brackets, I'm not providing any information. So what I'm telling the compiler is, hey, you figure out how big this is based on the initializer. Okay? So in this case, I've got 5 characters that I'm initializing this to. So the array will be size 5. So what's going to happen is I'll have an array of 5 characters, and I'm initializing them to A, E, I, O, and U. Right? The name of this array is vowels, so I can treat it as such, and it's indexed from 0 to 4. Remember, there is no 5 here, so don't let that confuse you. Fine. Now, in this case, I'm saying the first vowel is, and I'm using an output statement, and I'm grabbing vowel sub 0. Well, that's this guy right there. That's the little a. So I expect this to print out the little a. In this case, I'm using vowel sub 4, which is the little u right here, the lowercase u. All right, so let's run this and see what we get. So what I'm going to do is I'm pressing Control F5 to build and run. And the output is the first vowel is A, and I'll move this over here so you can see. The first vowel is a lowercase a, the last vowel is a lowercase u, exactly what we expect. Okay. Now, what would happen, let me clear this real quick. What would happen if I tried to read from the console and I want to store whatever character I read into vowels sub 5? Recall, there is no vowels sub 5, right? It goes 0, 1, 2, 3, 4. What happens here really depends on a lot of things. Obviously, I'm going to read a character and store it in a location that's not part of the array, so there could be something important there, and I just blew it away. My program will likely crash, depending on what operating system you're on and what you're running. Your crash may look different from mine. So let me run this and hopefully it'll crash. It may not. You never really know with this. Okay, there's first vowel is little a, second vowel is lowercase u, Now I'm going to read. So I'm going to type in, let's say, capital A. And when I press enter, that's my crash. Hopefully you can see that it says arrays.exe has stopped working. Close program. Depending on, again, what operating system you're working on, it may look different. But in this case, this is a good thing. My program crashed. I'm able to fix it. And obviously what happened here was, and I'll comment this out and I'll leave it commented out so it won't keep crashing. Oops, let me do that again. And I'll write something like, out of bounds. That way when you download in the example, you'll know what's going on. Right? I'll say, don't do this. Or be very careful with that. Okay, so that gives you an idea of what happens. It could be a pretty serious problem. And the real problem is that it may not happen every time. You may clobber some information that's just not even important. But you may clobber some information that's real important. Okay, so let's move on. In this example here, let me uncomment this code and I'll walk you through it. In this example here, I'm doing something very similar. I'm creating an array called high temps, and you can see that the name of the array is right there, high temps. Again, I'm not providing the size of the array because I'm letting the compiler figure it out based on my initializer list. There are 1, 2, 3, 4 initializers. So I was going to create an array of 4 doubles, the first one being 90.1, the second one being 89.8, and so forth. Here I'm saying print out high temps sub 0, right? Remember, this would be 0, 1, 2, and 3. So in this case, this will print out 90.1. Now I'm saying high temps sub 0 is 100.7. So what I just did was I just changed the 90.1 to 100.7. This is an assignment statement. We're going to talk a lot about assignment statements in an upcoming section, but they're really, really straightforward when you see them like this. All it says is move this guy into that guy. Okay, so that's what we're doing, is we're just overriding that 98.1 to 100.7. And then when I display it, it's going to display 100.7 now. Okay, so what I expect here is the first time I output that guy, it's going to give me 90.1. Now I'm going to get 100.7. So let's try this out and see if that's exactly what we get. Me build and run. The first high temperature is 90.1. The first high temperature is now 100.7. So here you can see some examples of declaring, initializing, and accessing array elements. Now here's another example here, and I'm going to comment this out as well. In this case right here, what I've done is I've asked the compiler again to give me an array of 5 integers and call it test scores. What's happening here is I'm getting an array of 5 integers. Just like that, it's called test scores. Again, they're indexed from 0, 1, 2, 3, and 4. However, I never initialized them. So what you have in here is junk or garbage memory. Whatever happens to be in there, whatever bit pattern happens to be in there is still in there. So what this code right here is doing is it's displaying each one of those array elements. It's starting at the element at index 0 and going all the way through the element at index 4. This is what we'll do later on with looping. We can do all this in one statement with looping, and we'll learn how to do that a little bit later. Now, when I do this, I'm expecting junk. I have no idea what's in those cells, so I don't know what's going to print out. So let's try it and see. And you can see the junk right here, 4199136 and so forth. There's a 0 in there. The point is, you cannot rely on those values. You really don't know what's in there. Okay, so what do? Well, we can just put a couple of curly braces there in the initializer. That will initialize everything to 0. So if I run this again, I expect to see all zeros. I do. That's exactly what I want. Always initialize your arrays. Never assume that they've got any value in there until you put the value in yourself. I could also put a hard-coded 0 in there, and I'll have the same effect. But what if I do 100? This piece confuses beginning programmers sometimes. You may think that it's going to put 100 in all of those elements, but that's not the case. Let me run it, and you'll see what happens. You see that? It put 100 in the first element, and then the rest are zeroed out. That's the behavior when you put in less initializers than you have. So watch now, if I put a 90 here, then what's going to happen is it's going to set this element right here. It's going to set this element right here to 100, this element to 90, and then 0, 0, 0. Okay, so that's the behavior when you provide less than the size of the array as far as initializers are concerned. So again, I'll run this real quick. And what you'll see is 190,000. Let me clear this screen real quick. In this case, what I'm doing here is I'm reading integers from the console and storing them into those array elements from 0 to 4. So whatever was in here before is going to be removed now. So I'm going to initialize this to 100. Let's just go straight down by 10, 70, and 60. So 100, 90, 80, 70, 60 is how I'm initializing this to. I have a 5 here. I don't really need that 5 there. I could just get rid of it like that. I did it before so you can see how it initializes zeros. So I'll just get rid of that 5 right there. It's still going to create an array of 5 integers and initialize them to 190, 80, 70, and 60. Now what I'm going to do is I'm just going to enter different numbers, and then we'll display those new numbers right here with this code, which is the same code as we used before. Okay, so let's do that real quick. We'll build and run. So there's our original array, 100, 90, 80, 70, 60. So suppose I want to go now 10, 20, 30, 40, and 50. And I print them out. Now you can see that array sub 0 is 10, and the next one is 20, 30, 40, and 50. So you can see that those values are read from the console and stored in the array. The last thing we'll do is, this may give you a little bit of a different effect than you thought. Suppose that I want to output just the name of the array. Now you'll notice test scores right here. I'm not saying test scores sub 0 or test scores sub 1. I'm just saying test scores. Let's run this, and then I'll show you exactly what's going on when we come back. So I'm going to run this. And again, let's just enter those scores again. And notice what happens here. It says, notice what the value of the array name is, and you get some hexadecimal number. That number is actually the memory address or the storage location where the array is located. This is the way that C++ works with arrays. The name of the array is the location of the array. Now that's a strange number to write, so I'll just use 1,000 for it. That way we can make it a little bit easier to explain. So let's take a look at how this works. I've created that array, right? Test scores. And test scores is 5 integers, just like we saw before. Again, indexed 0, 1, 2, 3, and 4. This is called test scores. Now, when I say test scores, what's it going to do? Well, it's going to take the address of that variable. That variable is an address. So let's say that the address is 1,000. And then this address is 1,004, assuming that we have 4-byte integers. And this is 1,008, and this is 1,012, and so forth. What prints out here will be 1,000. And the calculation that C++ is doing that we mentioned in the slides. So for example, when I say test scores sub 1, as I'm saying here, what it's going to do is it's going to take test scores, which is 1,000, and it's going to add 1 integer to it, or in other words, go 1 integer away from it. An integer is 4 bytes. There you go. That's the address. That's the calculation it's doing. This is why when test scores sub 5 is referenced, it's going to do the calculation and come up with that number right there, and it's going to try to work with this guy. Well, this guy's not part of the array, right? The array ends here, but there's no real boundaries around the array. It's not like protected or anything. So in this case, something is going to change, and it may be a bad thing. You might crash your program. Okay, so hopefully this example helps you understand a little bit about the syntax of arrays, how to initialize them, how to use them, and a little bit more about how they're laid out in memory and some of the issues that you can have with them.